Welcome to the Altair Optimizing Credit Risk Strategies through a low-code, no-code visual analytics platform session. Thank you for joining. I know there's a lot of great sessions in this conference, and we're happy to take a few moments of your time. In the next half hour, I'll talk to you about our data analytics platform and show you a demonstration of some of the capabilities. We'll focus today on data preparation and turning semi-structured data into structured data. We'll also create credit risk models that are no-code and node-based, as well as low-code, by illustrating our capabilities to code in the language of SAS and other languages. Finally, we'll incorporate our model results and demonstrate how we can take all of this hard work and create actionable business strategies. Before we get started, here's a little bit of background on myself. I have a degree in mathematics and actuarial science, and I've worked with big data in financial institutions and consumer packaged goods consulting before joining Altair 4 years ago. At Altair, I'm a team lead for our data analytics solution specialists. I aid our customers on their data analytics journey rapidly and visually with no code or fully integrated with code. I also help customers understand how to create strategic, actionable implications from their data analytics efforts. Our data analytics platform is an end-to-end portfolio that covers everything from data cleansing and preparation to AI and machine learning and to data visualization. Altair tools can access industry data sources directly with no middleware or coding needed, including third-party systems, all databases, cloud sources, websites, real-time streaming feeds, and even PDFs and complex spreadsheets. I'll show you today how to use Altair Monarch to cleanse and prep data that can feed into our predictive analytics. These processes can be automatically prepped and distributed. Altair's machine learning and data science tools are easy to use and support fast operationalization. Build models using our drag-and-drop visual interface, utilize existing Python, R, and the language of SAS, and put your models into daily use while constantly monitoring performance. I'll show you today how to use Altair Knowledge Studio to create models and business strategies efficiently in a way that promotes collaboration. I'll also take you through our language of SAS code node that incorporates SQL, R, and Python code as well. You'll see immediately what we mean by no code and low code. Altair provides the data visualization and dashboarding tools you need to facilitate informed, insightful decision-making and communicate effectively with executives, customers, and other stakeholders. We won't be taking you through this aspect of the platform. However, if you're interested, please stop by the booth for more information or contact us. Next question might be, who are the right persona for Altair's platform? Altair has the tools and expertise needed to support the complete data analytics lifecycle. Data engineers and other specialists can get up to speed with our software quickly, in hours or days, not weeks or months. Data scientists can take advantage of our full integration with open source, such as R and Python, as well as coding in SQL and the language of SAS. Models can be built quickly and visually for an ease of collaboration. This also offers a quick way of creating champion and challenger models. Credit risk analysts can build reports efficiently to fully understand the risk at the portfolio level or individual level. The drag-and-drop interface means we can support all levels of analytics sophistication. Our visual interface also makes it easy to communicate with non-technical executives and decision makers about how credit risk models work. This provides subject matter experts with what they require to be successful. MLOps engineers can take advantage of our models that can be generated in different languages of code. This enables an efficient, trustworthy production path. So why are we talking about credit risk today? Our tools are used for a variety of use cases across many industries. However, we are experts in credit risk. All type of loan originators, credit card processors, and collection firms use Altair to model risk profiles. We empower our customers to build their own application and behavioral scorecards, collection models, and other credit risk models. We also have a strong consulting team that can train our customers to get them up to speed quickly and implement our tools in their environment. Customers have the ability to store Altair in the cloud, on servers, or even on desktops to suit all requirements. Today, we're focusing on credit risk. As mentioned on the previous slide, this is not the only use case where we have aided our customers to be successful. Here's a subset of common applications through the analytics journey. Also, as written on the first slide, with data analytics growing at a rapid pace in countless directions, use cases for no-code and low-code solutions are also growing at a rapid pace. The time is now to start thinking about how analytics can make our businesses more efficient and effective. Now you know who we are. Let's step into the technical demo and see how we optimize a credit risk strategy using our low-code, no-code visual analytics platform. To start the demonstration, we begin with data, which is the hardest part of the journey. I'll demonstrate data preparation from data that came from a semi-structured data file in a PDF format. Here is the PDF file with information from loans we want to incorporate in our credit risk strategy. This is granular data of the loans in our portfolio. This could be data used in our machine learning models, or even data that might only be used to aid in actionable strategies and not specifically to train a model. This data prep is essential before moving into predictive and prescriptive analytics. Much like most of the folks here, we can push and pull data from a wide variety of sources, and here's an illustration of these sources. However, what we do that is unique is what I'll be showing you today, PDF extraction. We will open our PDF file in Monarch. This triggers the report designer to enable capturing the data from a PDF. How Monarch does this is like putting a piece of paper on our PDF and cutting holes where the most pertinent data resides. The two things you need to know are traps and values. We use traps to identify where those holes should be located and the values to determine the shape of the holes. Here I click on Auto Define to get the software to automatically create the traps and choose the values. This is how it's done automatically, but you're always in the driver's seat and can define the traps and values manually. Once we're happy that all the pertinent data is being collected, we accept the report design. This now has transformed the data from a semi-structured format to a structured format in rows and columns, and we move into Data Prep Studio. This is where our no-code data preparation can begin. We can cleanse our data with common functions, and we can also create calculated fields. Here we have deleted some columns and transformed the data for further reporting or to add to our machine learning model process. Some of the highlights of Monarch Data Prep Studio are the change history is included, so we know exactly how the data was prepared. This is advantageous for data lineage and data governance. Other capabilities of Monarch are we can transform the data by sorting, removing duplicates, grouping, and other capabilities. We can combine tables through joining and appending. We can also create summaries from the data, which will be used for various reports. Finally, we want to export the data. Here we're illustrating all the ways we can export a specific table. We will save this final workspace to use again when another PDF report in a similar format is available. The workspace is completely repeatable. Once you've created the workspace, the hard work is being completed. You can apply this to new PDFs that are in the same format. We can also automate the process and have this scheduled at whatever cadence the PDFs need to be prepared. It can be scheduled by time or the availability of the files. The prepped files can then be distributed via email or to a specific location. To summarize, we have extracted the data from the PDF without manually copying and pasting lines. We did this by setting up traps and values. Once the data was in a structured format, we could perform all of our data preparation steps, save the workspace, and have this automated at a regular cadence. Now we can move to machine learning or predictive analytics to continue our journey to optimize our credit risk strategy through a low-code, no-code visual analytics platform. In this particular credit risk project, we have a portfolio of loans, and we need to determine if there is a subset of loans that might require us to fund them with other assets. We need to know what is the probability of default of each loan and action by funding or investigating the riskier loans. By training a machine learning model on historical loans, we can assign these groups of loans the specific strategies. Not to spoil my demonstration, but this is where we want to get to. Before we get there, I'll give you a quick tour of Knowledge Studio. The software is set up across 7 palettes that follows the same process as a predictive model. The first step is to connect to data. It's on this palette where the nodes enable pushing or pulling data from various data sources with imports and exports. We can connect to Excel files or text files or from a database with an ODBC import node and many other capabilities. The next 2 palettes, Profile and Manipulate, are for action items or nodes to complete the data exploration and data preparation stages of the model flow. On the Profile palette, there are nodes that can remove highly correlated variables or variables that have no predictive power. Under Manipulate, we can manage our data by having the ability to join or append datasets. There is also the ability to create new features with our data transformation node, which I'll take you through today. The model palette is where the power of Knowledge Studio resides and the heart of what we do. Today we'll use a decision tree and a logistic regression for our machine learning credit risk models. We also have a patented model called a strategy tree that might look like a decision tree, but it has a very different function. This model will be used as our prescriptive analytics solution that will provide strategies or actions from using the modeled results married with our own business knowledge. It is important to point out here our other modeling capabilities. We also offer nodes for both supervised models like regression models, ensemble tree models, and neural nets or deep learning, and unsupervised models like cluster analysis. These other models can be invaluable for credit risk analytics and could be the source of another conversation should you want a deeper dive in the future. Once we've created our models, we want to make sure we deploy the most predictive model. The Model Analyzer node is on the Evaluate palette, which provides the ability to compare models and determine statistically which model is most predictive. The Evaluate palette provides nodes to understand how our models have performed. The Action palette provides nodes to deploy our model. Scoring the model is possible from this palette, as well as creating your model in several programming languages like R, Python, and other languages. We have optimization nodes on this palette to create a prescriptive analytics solution at the record level. The Python, R, and language of SAS code nodes enable the ability to code in these languages and save the code to create nodes that will reside on our final custom palette. It's on this palette that really shows the code aspect of our software. These nodes can be used on future projects and shared with colleagues. A predictive model process is drag and drop from nodes on a workspace to enable the visualization of each step taken in the modeling process. This is handy for yourself to reference later, but it's also very helpful with regards to collaboration. Collaboration becomes seamless when you can visually see what steps your colleague took to create a model in comparison to reading through lines and lines of code. Like a good cooking show, I've already created the project on another workspace. Here on the workflow, blue squares represent the nodes or action items, and data is always represented symbolically with a green circle. The use case behind this project is to understand the overall risk in a loan portfolio. We have performed some data preparation steps with nodes at the top and run 2 machine learning models on our historical loans. The model that performs best, which spoiler alert is our logistic regression, will be applied to our current loans or current portfolio. It's here where we get to apply all the hard work we've done and create actionable business strategies from our models. We apply our data and data science to make our business more profitable. As mentioned before, every data node is represented with a green circle, and that has the same series of sheets to aid in data exploration. First sheet overview report provides summary statistics for each variable. The next sheet illustrates each variable graphically. It's imperative that our data is correct, or a predictive model is useless. In this data set, our dependent variable is target. In other words, the variable we are training our model to predict is the binary variable target. This represents all the loans in the data set and if they were good or bad. From the summary statistics, the dependent variable has a cardinality of 2, with values bad or good. Graphically, the variable shows 66% of loans were good and 34% were bad. This is in line with our expectations, so we're comfortable that our dependent variable is correct. Another very useful tool within a data node is the segment viewer. Here on the right-hand side, we have every independent variable visually illustrated by the value of our dependent variable. On the left-hand side, the statistics, information value, and entropy explained are calculated for each independent variable. These statistics measure the degree of predictive power for each independent variable. This is a useful tool since some of our clients have hundreds of independent variables, and it becomes possible to quickly understand which variables have no predictive power, in our case like policy code. This tool can also save a programmer a lot of time. It's tools like this that have helped our clients save 50% of their time on model creation. If there's anything uncovered in this data exploration phase of the process, we have nodes that can perform these tasks. For instance, if there are variables that should be removed from your data set, the variable selection node can do this quickly. If there are highly correlated variables, as uncovered on our correlations tab, the multicollinearity node will automatically remove them. Before we go further in the creation of our credit risk models, I want to highlight our integration with code. This is becoming more and more crucial as data science is growing and essential to our software. A gentleman stopped me and said, "I don't need no code, I need code." I told him that he was in the right place. I created a variable transformation node on the canvas to create the dependent variable, and you can see how I did that here. However, in parallel, I've run the code in our language of SAS code node that does the same thing. Clicking on the node, we are quite simply recreating that data transformation in SAS. With Altair's acquisition of WPL, we now have the capabilities to run the language of SAS, SQL, Python, and R all in one place. There's only 2 companies that can do that, Altair and SAS. When I click on the code node, I can run an IDE that allows you to program in the language of SAS. In addition to opening the IDE, the SAS language code node enables us to save the code as a separate node. Here we've done this and labeled the node data transformation. This means we can use this node on future projects and share amongst our colleagues. Most of this functionality is also available in our Python and R code nodes as shown here. I hope you now understand our product can be no code, but also is fully integrated with the language of SAS or open source languages like Python and R. Now let's get back to the canvas. You'll remember we uncovered some data preparation steps we still need to take, removing highly correlated variables and removing variables that have no predictive power. These were done in the data preparation section of the project. We ran our multicollinearity node and our variable selection node. Once this is completed, we can partition the data with the partition node and get test and training data sets. Now we have completed our data preparation and move on excitedly to the creation of our machine learning models. For this project, we've run 2 machine learning models a decision tree, and a logistic regression model. Knowledge Studio is known for their decision trees that are explainable and interactive. It is our model which is imperative to our customers. All our nodes are wizard driven, so let me take you through the wizard of the decision tree. We first define our dependent variable, and next I've chosen the default split search method and measure. The beauty of Knowledge Studio is it adheres to anyone with a knowledge of predictive analytics. If there are certain parameters defined in your organization or prepared due to the knowledge of different measures, the tool is flexible to incorporate. Or you can create the tree as I have here with the defaults. The split search method defines how many leaves or nodes each branch will have. The measure identifies how predictive each variable is, or in other words, how close each variable is to the trunk of the tree. The next page, we identify the variables we want to include in the model, and then define the stopping criteria if we are automatically growing the tree. Once we're in the output of the model, we can visually see the probabilities of default in every node and identify which variables are most important to make the default prediction. The model output is interactive and can be pruned easily by editing splits. There are no models that are as explainable as a decision tree. If I erased all child nodes, the variable that is most predictive is subgrade. So this is not a surprise, as this variable would have been created from other machine learning models. The decision tree can be built automatically or branch by branch. Now the decision tree has been refined. We can create this tree in various languages of code as shown here. I will generate the tree in Python code. We created a decision tree. Let's create a logistic regression model and compare the results. Similar to the decision tree, the wizard steps us through the inputs required. We run the logistic regression model and look at the model output from the last sequence of the stepwise selection. The output is not as visual as our decision tree, but we still get a flavor of how the variables are being used to calculate the overall outcomes. Once we've validated both models, we can add the model analyzer to the project. The model analyzer node takes the validated data set from each model. 4 different charts are illustrated in order to get a full picture of the predictive models. There's the cumulative lift chart, KS chart, and ROC chart. For me, the ROC chart is most intuitive by charting the false positive rate and the true positive rate. When looking at the 4 charts together, our logistic regression model was most predictive and the model we should deploy. So this completes our machine learning model training. Where do we go next? We need to put this work into action and create actionable business strategies. We now want to score our logistic regression model with data where the outcome is unknown. We have a data set of current loans where we can apply our machine learning model and understand the probability of default on each loan. This is our prescriptive analytics piece and getting to defining our final credit risk strategy. Our strategy tree is designed to add these strategic actionable business implications by using results from a machine learning model married with our own business knowledge. We have manually created a variable to layer in the business value piece, and that variable is appropriately named value. The business goal of the strategy tree is to determine what loans in our portfolio are risky and need to be funded or investigated. To do this, we add calculations to the nodes to identify the total value in each node and the percentage of value in that node. Once again, like a good cooking show, I already have this completed and you've already seen it. This is a very simple example of our strategy tree, but a good illustration of the capabilities. In our first branch, we forced a split on the output from our model, which is the probability of a bad loan. For this project, we're only concerned about loans that have a higher than 50% probability of default. We then split those records by value, layering in our business knowledge through the variable and with our calculations. Once we've split the records, we can assign treatments to the nodes. These are strategic actions. In this example, we'll require additional funding for loans that are riskier and have a value over $4,000. We will investigate the loans between $1,500 and $4,000. Loans less than $1,500, while they're still risky, only make up 2% of our portfolio and do not need further action. Again, this is a very simple example, but we know exactly how to action from our data science. Very last steps, we can score this strategy tree, and we are left with a data set that has these actions now incorporated as a field. This data can be partitioned as different data sets to aid in the execution of these strategies. This is the end of the session. I hope you take away what Altair's platform can do and how we can optimize credit risk strategies through a low-code, no-code visual analytics platform. In today's session, we scraped data from a semi-structured format and prepared it in Monarch's Data Prep Studio. Once the data was in a structured format, we could perform all our data preparation steps, save the workspace, and have this automated at a regular cadence. We developed 2 machine learning models and illustrated that can be done with nodes, but also with code in the same platform. We then created actionable strategies using our strategy tree, where we used business knowledge married with data science. This left us with data that incorporates all of our calls to action. Thank you for listening in, and please contact us if you have any further questions. We'd be happy to help. Thank you.